All right, so which questions do you want to work through? Which one? Number 2? All right. So looking at number 2, what we're starting with is describing our end behavior. To describe our hello screen, thank you all. That was a choice. Ooh, that was a big marker. All right, so the first thing we're asked is to describe the end behavior, which is all well and good, except I can't describe the end behavior without doing these 2 first. Thank you, sir. So we need to start with our degree and our leading coefficient. So what is our degree? 4. The degree is our exponent. What is our leading coefficient? -5. So what we have here is that this is an even number, and this is a negative number. The leading coefficient, we care if it's negative or positive. The degree, we care if it's even or odd. An even negative has the same general shape as a frowny face parabola. From there, we can get our end behavior, because our end behavior has them matching because they're even, and both going down because it's a negative. So we're going to have negative infinity for both of these. As x's go to the left, the y's go down, and as x's go to the right, the y's go down. The trickiest one up here is that domain and range, because it's been a hot minute. So what we're going to do is we're going to think about this little sketchy sketch we have down here, and the fact that I don't have anything added onto the end here. Like I don't have any b terms, I don't have any plus a constant or anything like that. So what that means is we're going to have our 0, 0 be kind of the middle. So, boop. So when it's just the one term, it's going to kind of be like this on a graph. And I hate that line. We're going to try that again. There we go. That's better. And so domain and range, we're just kind of getting a vibe of it. We're not getting like a true 100% domain and range. But what x values could we use in this? What could be our domain here? All real numbers. This goes all the way out to both sides. So all real numbers. What about for our range here? Where are our y's all living? If this is, say it again? The negative numbers, right? So the way we word that with a range is we can say either y has to be less than or equal to 0, or if you want to use the infinity thing, it's negative infinity to 0 with the brackets thing. Yes, dear. Because we don't have a like y-intercept, if it was like +2, that would put, well, that was not the eraser. If it said +2, we would have this be at up 2. That would be our y-intercept. We're not, like, the domain and range is not the thing to focus on, sweetheart, okay? get the vibe of it, we're just getting take our little sketchy sketch and give me the domain of our little sketchy sketch. Domain and range of our sketchy sketch. It was one of those, I want us to practice our domain and range stuff a little bit. But all we're really asking is it one-sided, or is it going to be all real numbers where it goes across the whole thing? And this one is one-sided, only covers the negatives. The last piece of this is to estimate or to find the value when x equals 4. I need a different color. What we do to get the value when x is 4 is we substitute it into our equation. So we're going to calculate y equals -5 times 4 to the 4th. And the way we're going to do that is we're going to type it in the calculator. Yay, shut up. So we have -5 times 4. And then our button that lets us do any exponent is this one right here. And that lets us go up into the exponent, and we can put in the 4. So it's typing it into the calculator. And we get -1280. Okay. Questions on that one? I'm just kind of getting the vibe on the domain and range. It's not going to be super specific. We don't have anything added on the end, so it's always going to be a 0 over here. If there's nothing added on the end, it's a 0 as your y-intercept. What do you guys want to do next? I heard 3 and then 6. So 3 is very, very similar. And this has one question that I call I'm a jerk. Same kind of vibe. We're going to start with our leading coefficient and our degree. What's our degree here? 4. It's this guy in here. It's the biggest exponent. Whatever your biggest exponent is your degree. So our degree is 4, which means what's our leading coefficient? 8. The leading coefficient always comes with that term. So those are the pieces that decide the end behavior. The biggest exponent decides our end behavior. So if it is a positive even, because this guy is positive and the wrong color, so this one's positive and this one is even, it's going to be vaguely parabolic. It's going to have the same end behavior as the smiley face parabola. I don't know why I did it with a highlighter. There we go. That feels better. So that means our end behavior, with both of them pointing up, they're both going to be what? Positive infinity, yeah. So the end behavior is just describing our arrows. On this one, what is our domain? Super close, but not the domain. The domain doesn't stop at 0. What is our domain? Domain is our x's. Remember, what x's can I use? All real numbers. Or you can say from negative infinity to positive infinity. Both of those are valid. And on the answer key, I did write them in interval notation, like that, with the negative infinities. So the range, as much as we have right now, it does look like what you said, Yasmina, where it would be 0 to infinity. However, because I'm a jerk and give you a polynomial and then ask you to find the range, we actually cannot find it. We don't have enough details. So this question is called I'm a jerk. So this is not enough info yet. We don't know yet. So I am not going to ask you domain and range of a polynomial on the test. Like, at most, it'll be a monomial, these guys down here. Because these guys we can tell. We can give ourselves a little sketchy sketch. We know our y-intercept. We know what it's going to be. We can do domain and range here. This one is called, I copied and pasted the fill in the blank parts and did not pay attention to the fact that the range on that would be a jerk. So I will not ask you the range of a polynomial on the test. That is not going to be on there. Okay. Our last piece on this one is evaluating when x is 5. And that's when we go through and we substitute it into our equation. So we're going to have our negative 4 times 5 cubed plus 8 times 5 to the 4th minus 7 times 5 squared, that's a bad 5, squared plus 6 times 5. And we're going to type that in the calculator to get the value. So I'm going to go do that. So we have negative 4 times 5 to the 3rd plus, we got to get out of the exponent before we hit plus, plus 8 times 5 to the 4th. And then I hit that right arrow to get out of the exponent. Minus 7 times 5 squared plus 6 times 5 equals 4355. So it's a big number, but it's just practicing typing it into the calculator. 4355. Alrighty, what else? 6, thank you. I was like, you already took that one. I knew there was one. 6, let's look at 6. Ah, the table one, yeah. So let's look at this table. And we're asked to figure out where the zeros are located. This is when we remember we talked about it. It's called like the fundamental theorem of algebra or something, is that if I have a point that is below my x-axis and I have a point that is above my x-axis, somewhere in between there is a 0. So what we're looking for is where it changes from negative to positive or from positive to negative. So here we actually have quite a few. because right here, my y values switch from negative to positive. So we have a 0 between -2 and -1. I have another one when it switches from positive to negative. So we have another one between -1 and 0. And we actually have one more because we didn't give you enough lines because we weren't paying attention. Down here when it switches from negative to positive again. So we have another one between x equals 1 and x equals 2. We're looking for where that sign is changing. It went from negative to positive, then it went from positive to negative, then it went from negative to positive again. So we're looking for those sign changes for those zeros. For where we have extrema, we can either look at our signs and realize that this is small, bigger, smaller, from negative to positive to negative, or you can give yourself a little sketchy sketch. So -2, -25 is going to be real low. -1, 2, it's going to be somewhere real close to my axis, but a little up. 0, -1, 1, -4, and 2, 23. So if we do that, we can start to see some extrema. And remember, we don't have enough information to say there is an extrema at. We say it's near. So we have a maximum near this little baby peak right here, where it changed directions over here. So we have a maximum near x equals -1. That is not a pen. And we have a minimum near where? Where's our other one? Well, we had a maximum near -1, so I can't have a minimum there too. Where's our minimum? 1. I have no idea what I wrote on the answer key. It should be a 1. It looks like -11, and I'm not entirely sure where that came from. Just saying. I'm looking at the answer key. I don't know why, but it says -11. There's not a -11 to be had in the problem. So I'm not entirely sure where my brain came up with -11. I'm going to go fix that right now, and I will re-upload the answer key. Because the answer key is up. But yeah, that was a strange choice. Okay, so we're looking for those sign changes, and then we're kind of looking at our shape to try and identify those peaks or valleys. You can either realize that here is definitely the highest number in its neighborhood. Here is definitely the lowest number in its neighborhood. It is the lowest as it is between things. Yes, sir. So you don't have to, if we ask you to find, let me show you which one. So if it says something like determine the quotient, or simplify or divide, you do not have to factor. If it says simplify using any method, you do not have to factor it. Bring that in so we can see it. This just says simplify. This says find all the roots. So this means then we factor afterwards. This just means divide, however you want to. This one means divide, then factor. Okay? Do you want to do one of these? 12. Let's do 12. All right, so our first question up here is when we divide, let's see, let me get a highlighter because this really smooshes together, this polynomial by this piece, and we set up our synthetic division, which remember synthetic division turns division on its head, so it goes upside down. What they mean by in the box is they mean here. What number is going to go here? -5. Because some people draw it like this. That's what they mean by in the box. I feel like that's doing too much and it makes my paper look super complicated. So we put our -5 over here. Then we're going to do our division. What are our numbers going across here? Walk me through it. What numbers am I going to put here and here? Exactly right. 3, 11, -24, and -20. Then we're going to do the operations. First term is going to drop. Always does. That first term will always drop. So then we're going to have 3 times the -5, and what goes here? -15. What goes here? Yes. -4. Here. Yep, -20. Oh, not -20. -5 times -4. +20. And here, -4 again, which means here goes, careful, -5, -4, +20. And because when we add them together, we get a 0. This last term is always the remainder. Then it goes up by a degree. This is my constant, so degree 0. This is my x, or degree 1. And this is my x squared, or degree 2. And we've run out of terms, so that's where we stop. So our polynomial answer for our division is 3x squared minus 4x minus 4. Questions on that part of it? We're not done, but on that part. Because we were not just asked to simplify, we were asked to find all of the roots. That means we need to factor. So we're going to come down here to this guy, our answer from the first part, and we are going to factor this. I'm going to do that with our x and box. And this one's a tricksy one. Because we put our a times c at the top. What number is going to go at the top of our x frame here? Very close. -12. Our b goes at the bottom, and that's -4. We need a pair of numbers that multiplies to make negative 12 and adds to make negative 4. Negative 6 and positive 2. Negative 6 times 2 gives us negative 12, and negative 6 plus 2 gives us negative 4. From here, we're going to fill in this box. 3x squared from the equation. The minus 4 from the equation. And then these numbers tell us how this variable is split. So it's minus 6x and plus 2x. And then we need to come in here and pull our factors. So what is shared between 3x squared and minus 6x? What's our common factor in this first row? 3 and x. What is shared in the bottom row between 2x and minus 4? 2. What is shared between 3x squared and 2x? Just an x. And this last one will be the one that kicks people in the teeth. What is shared between minus 6x and minus 4? But watch the sign, because it needs to match this one here. So it's actually going to be negative 2. So our factored form of our quadratic is being annoying. Come on, pen. X minus 2 and 3x plus 2. And we're almost there, but this is one of the longest ones in the packet, and that's okay. Because we need to find all of our roots. So what roots do we have? Yep, so when this thing equals 0, we have positive 2. What other ones do we know? Negative 5 is one of our roots. And then our last one is the hardest one to see. Because we're taking this guy, and what we're going to do is we're going to set it equal to 0. I'm going to zoom like way out for a second because I need, actually no, I've got space over here. We're going to take 3x plus 2 and set it equal to 0. To find our root, we set it equal to 0. So what do we do to find x all by itself? Subtract 2. So we have 3x equals negative 2. And I want to know what x is. What is x? What do we do to get x by itself here? Divide by 3. So x is negative 2 thirds. And that's another root. And that's okay. We can have fraction roots. Come on, comma. Pen's being a jerk today. We can have fraction roots. That's okay. Yes, dear.
Where did you get negative 5?
Negative 5 is the one that we got from here. Okay, so this is still a root. It's what we divided by up here. So if it's all roots for this polynomial, that's got to include the guy that we divided by. What next?
4.
4. 5. So let's get 4. What best describes a function? So a lot of these will have a lot of different names. And we're just looking for which one is the best function name. So polynomials means we're looking for our exponents. Our exponents need to be positive, and they need to be whole numbers. No fractions, no decimals, no weird things going on. Quadratics are polynomials, but they're more specific. Quadratics have a degree of 2. They must have a degree of 2. Linear functions, again, they're polynomials, but they're a little bit more specific. They have a degree of 1 or 0. So they're still polynomials, they just have more specific names. So I'm just going to put a thing on here. So for polynomials, we're looking for positive and whole. That is not how that's. Sorry, y'all get to join me on my zoom in so my handwriting doesn't suck. And that's in the degree. I don't care about the numbers. The coefficients can be whatever the heck they want to be. But the degree, my exponents, my powers have to be positive and whole. And we can't have like weirdo funky things going on. So looking at A, what is its degree? What is the biggest exponent I have on a variable? Do I have a variable here? 0. So this has a degree of 0, which makes it a line. That's all a linear is that it's a line. So this is linear. But we're looking at that degree. That's how we tell. So then let's look at B. What is our degree here? Bring it in. What is our degree here? What is the biggest exponent we have on a letter? Is that an exponent or is that the coefficient? That's the coefficient. So what's the exponent that it has? Not 0. 1. If there's nothing written there, it's an invisible 1. Every number has a 1 exponent. We just don't write it because it looks super gross. So this has a degree of 1, which makes it what kind of function? Linear. This is a line. It just has a slope of 1/2. This is mx plus b. It's a line. What do we think that C is going to be? Is that a polynomial? Because of the square root of the letter, this is not a polynomial. So this one is none. If you have a letter under a root, it is not a polynomial. It is a radical. It doesn't matter if there's a number under there, but if there is a letter under there, no bueno. Let's look over here on this right-hand column. What is our degree for part D? 5, 2, and 1 are our exponents, but our degree is our biggest one. Our degree is 5, which means what name does this kind of function have? Of our name options. Polynomial. I should have did that in pink. So we're gonna go. So this, since it has a degree of 5, is a polynomial. How about this one where we're dividing by x? Is that a polynomial? Is that something we can do something with? Have we ever divided by x's so far? Mm-mm. We will eventually, I think, March. We'll play with these guys. But for now, we don't know what these are. They are technically called rational functions, but this is not a polynomial. So this would be a none. We are not dividing by our variables yet. We will be able to eventually, but not yet. How about for f? What is our degree? 2. So what name does this function get? Quadratic. This is a parabola. Okay, so this one was none because we divided by x. And this one was none because of the square root of a letter. Which one? 13. And that's probably going to be our last one because we are like 5 minutes from the announcements. So 13 is the very last one. So we're going to use any method to simplify. How do you guys want to do this? Do you want to do this with synthetic division or long division? Synthetic. So we're going to build this guy out. You can absolutely use long division for it. Totally fine. It will still work. What number is going to go here? 3. It's where this piece equals 0. So it's our first root. What are my numbers going across here? 2, -3, -14, 15. Good. So we've set it up beautifully. What happens first? Bring down the 2. What next? What goes here? 6. What goes here? 3. What goes here? 9. What goes here? -5. What goes here? -15. And what's our remainder? 0. So what is our answer? What is our polynomial answer? 2x squared. Careful of your signs because this is plus 3x minus 5. Super close though. Okay, we were not asked to find all real roots. So we can stop right there. I did, on the answer key, I did find all roots because it's good practice. So if you want to see that, it is up on the answer key that is up on Canvas. This one does factor. It factors out nicely. Actually, honestly, a little bit nicer than the one above it. But it's good practice, but it wasn't in the instructions. So I did it, but you don't have to. Okay, so work through stuff. Keep practicing things. But we have a minute until the announcement reminder bell goes off. So the answer key is up on Canvas. The answer key for all the homeworks are up on Canvas. Yeah. Test is tomorrow. We gonna rock it, y'all. I believe in you. What's up?
Question about the range.
Mm-hmm.
What would be the range?
Say it again.
What would be the range?
So since it's going down and up, right? It's covering everything. Since our domain covers everything, we had all real numbers. Our range covers everything. So what's it going to be? since it's going all the way, right? Yeah. Or you can say, I'll remember. Okay? Oh, what up?
Can I get another review?
Yeah, they're the behind the worksheet that's been pushed up. So behind that one. Yeah. That's it.
Can I also get a pass to go take down this paper to Miss Grimes?
Let me get put up on the screen first.